Okay, so today we're looking at section 6.5. We're going to be talking about the properties for logarithms. It's on page 176 in your student journal, but we're just taking our notes on our Chromebook. So these notes will be slightly different from what's actually in your student journal. So the properties of logarithms. This first property states that if we have a product in this position right here, if there's a product in that spot, then we can rewrite this as log base b of m plus log base b of n. I want to do number 2 in our warm-ups by using this property. Number 2 in our warm-ups was this problem. It was log base 3 of 81. What was the answer to that? Okay, now let's look at another way that I could have done this problem. What are some numbers that multiply to be 81? 9 times 9. So based on this property, if I have a product here, I could rewrite this problem as log base 3 of 9 plus log base 3 of 9. That's another way I could do the problem because it was a product. So what is log base 3 of 9? And again, so our answer is 4. So that's how that property could work. So if you knew you were trying to do this problem, but you weren't sure of how to do it in this way, you could think of numbers that multiply to be 81 and then rewrite it. Okay? That can be very helpful. The second property we have is the quotient property. And this says that log base b of m over n is equal to log base b of m minus log base b of n. We didn't have one of these quotients in our warm-up, so I'm just going to make one up, just an example. So let's say that we're trying to do log base 5 of 125 over 25. Well, because this is division, I could make this subtraction. I could do log base 5 of 125 minus log base 5 of 25. What's the answer to this? 5 to the what is 125? To the third. So this answer is 3, isn't it? What's the answer to this? 5 to the what is 25? 2. So that's 2. And so this answer would just be 1. That wasn't that difficult, but maybe it would be easier. What's 125 divided by 25? 5. So another way of thinking of this problem would also be log base 5 of 5. And what's the answer to that? 1. So see how these properties work. The last property is the power property. It says log base b of m to the n is equal to n log base b of m. Well, let's look at number 4 from our warm-ups. Number 4 from our warm-ups was 1/2 log base 5 of 25. Well, looking at this property, it says if I have a coefficient, I can make it the exponent of this number right here. So I can make this problem log base 5 of 25 to the 1/2. What is 25 to the 1/2? 5. So now it's log base 5 of 5. And what's that answer? 1. And that's the same thing we got in the warm-ups. Okay? So those are just examples of how these properties work. Okay, we're doing change of base tomorrow, so flip over to the back. These kind of problems are always on the ACT. We will be given some information about the logs. For example here, log base A of 5 is about 2.322. Log base A of 12 is about 3.585. And I want to use that information to evaluate these. So I'm going to do numbers 2 and 3, and then I'm going to have you do 1 and 4. So let's look at number 2. When I have division, what does it turn into? Subtraction. So this is going to be log base A of 1 minus log base A of 144. But the only numbers I'm given information about are log base A of 5 and log base A of 12. So what's another name of log base A of 1? In other words, A to the what power would be 1? 0. So this is just 0. For this one, I'm going to have to think of it as log base A. I want to use the number 12. So I'm going to have to think of 144 as being 12 squared. With the squared, I'm allowed to bring that out in front. So I would have negative 2 log base A of 12. Well, now I can look up above. Log base A of 12 is just 3.585. So all I have to do is negative 2 times 3.585. I can just grab a calculator. And that's going to be negative 7.17. Okay? All right, actually, I'll do number 4. I'm going to let you guys do 1 and 3. So number 4, 720. What would make the most sense to divide 720 by? Do I want to divide it by 2? No, I don't know anything about log base A of 2. It's not helpful. So what would be something good to divide it by? 12. So I'm going to do 720 divided by 12. And I get 60. All right, well, that's helpful. But what should I divide 60 by now? 12 or 5, one of those. I'm going to divide it by 12. And I get 5. So now I know that 12 times 12 times 5 is 720. So I'm going to rewrite this as 12 times 12 times 5. Then I have to know that when I have multiplication, that turns into addition. So it's log base A of 12 plus log base A of 12 plus log base A of 5. And now I can just substitute those in. So log base A of 12 is right here. So 3.585 plus, there it is again. And then finally plus 2.322. And I get 9.492. All right, I want you guys to try 1 and 3 now. When you're finished, check your answers. Any questions on those? All right, so now we're going to do a process called expand the logarithmic expression. When you see the word expand, it means that we want to have as many logs as possible. So expanding, of course, means to make larger. I'm going to do 7 and 8. You'll go back and do 5 and 6. So on number 7, expanding this. It's just like what we did up here, except now we're going to have variables instead of numbers. So on this one, I have division. So it's going to turn into subtraction. So I'm going to have log base 3 of x to the 4th minus log base 3 of 3 minus log base 3 of y cubed. See, this 3 is a factor by itself and y cubed is a factor. So I could separate those two. So now, right here where I have this x to the 4th, that can come out in front as a coefficient. What is log base 3 of 3? We should just go ahead and do that. What's log base 3 of 3? 1. So I can just replace that with 1. And then on this one, the 3 comes down in front, so it's 3 log base 3 of y. So again, any factor that's in the denominator has to become subtraction. If it's in the numerator, it has a positive in front of it. All right, for this one, I'm going to start off by trying to expand this, but I've got to realize that something's happening to both of these. See, this is the same as natural log of 3y squared to the 1/4. You guys see that? How both of these are to the 1/4 power? So where do I put the 1/4 in? Where do I put this 1/4? In the front. So now I'm going to have this. So the 1/4 is in the front. So what is this going to turn into if I have a 3 and a y squared in its multiplication? What's it turn into? Addition. So now it's going to be 1/4 natural log 3 plus 2 natural log y. But I'll tell you that there's something wrong with that. Does anyone know what's wrong with that? Yeah. Yes. See how the 1/4 goes with both of these? If I just put the 1/4 here, then only this one is to the 1/4 and not this. How could I correct that then? Use what? Well, I could just put parentheses in there, couldn't I? Just do that. And now the 1/4 is for both of them. So you could either give me this answer is good. You could also give me this answer. You see how that would be okay as well? And do you see how if I go back up here and check this, see how this would be y to the 2/4, which would be 1/2 out in front, kind of checking that. All right, you guys try 5 and 6 now. Ben, what did you get for number 5?
Log. Wait. So, would you just take the log? Couldn't you just take the log of 10?
Yeah, but you should expand it first.
Okay, so you would just do log of.
Be log 10 plus log x. And then what is log 10? So it's 1 plus log x. So you can either have it written as 1 plus log x or log x plus 1. If you wrote it as log x plus 1, would you put parentheses around the x plus 1? No. In fact, that would make it incorrect to put parentheses around that. All right, what about for number 6? Anyone have that? No one's sure about number 6? Anybody want to guess? Ella, you look like you could guess for me.
Is it 6 parentheses natural log 2 plus natural log x?
What do you guys think? Do you agree with that? That's actually not right, and here's why. If we wrote it like this, that would mean that it's 2 to the 6th. Is 2 getting raised to the 6th? No, just the x's. So we would not want to do this. We would just want to do natural log of 2 plus 6 natural log of x. That's the way we'd want to have it. Because now it's saying only the x is to the 6th and not the 2. You see the difference, Ella?
Yeah.
Okay. All right, let's come down here now. I'm going to do the last 2. So now we're going the other way. We're trying to condense. And this means, when it says condense, that means we want a single log. Just one. All right, so looking at number 12, and plus all our bases have to be the same. So I have a log, log, log. The bases are all the same. So now what I'm trying to do is make it just one log. So it's going to be log base 2. 625 is positive, so it goes on top. 125's log is negative, so it has to go in the denominator. This 1/3, I might as well simplify before I put this anywhere. Where can this 1/3 go as a what? Exponent, so it becomes to the 1/3. What is 27 to the 1/3? And where does the 3 go, top or bottom? Top, because it's plus. So 3 on the top. So now I want to evaluate this if I can. Well, what is 625 divided by 125? That's going to be 5 times 3. And so now I can just simplify that further, and this would be log base 2 of 15. That would be how that simplifies. So if I simplify all of this first, it's a lot easier to put into my calculator now, because all I'd have to do is go to my math, go to log base, and I could just put in log base 2 of 15. And there we go. All right, let's go ahead and look at 13. So our base is the same everywhere. So I have log base 6. Now where's that 6 going to go? Right, has to go in the denominator. What about this 2y? Where is it going to go? In the denominator. And then this 2, well, this 2 I can put here. Now, would it just be 3x squared, or is it the entire 3x that's getting squared? Morgan?
Isn't the denominator because it's negative?
Right. Anytime it's subtraction, it goes in the denominator. But back to this question. Is it just the x that's getting squared, or is the 3 getting squared too? Yeah, so I would have to think of it like that. So then what's going to go in the numerator then? 9x squared. And so now we just want to simplify this. So this could be log base 6, and this could, 9 divided by 6 can cancel to 3 halves. So I would have 3x squared over 4y. And that would be a condensed form. Now, you could also make the argument that you could do this. What is log base 6 of 6? 1. So I could really have -1, and then I could have plus log base 6. This would go in the numerator as 9x squared, and because this is a negative, it would go in the denominator. So you could also have this, but I think that this is actually easier to work with because it's just one expression. But these two would be equivalent to each other. They would be equal to one another. Okay? All right. Let's go back up here now, and you guys try to rewrite these as a single log. Bless you. Sam, what'd you get for number 9? Log base 2 of what?
3 plus 2 is logical.
No, it should be log base 2, and then you should just multiply the 3 times the 8. So it should just be log base 2 of 24. How many people got that right? Okay. What about number 10 then? Log base 5 of what? What do you think, Ben?
4 over 25.
Right. So the 4 stays in the numerator, this comes here, and because it's subtraction, it goes to the denominator. Okay, and then this last one is a little bit tough. I think I know. Lee, what'd you get?
216x to the third numerator and 4
Very good. This 3 goes with both of these. So this is 6x quantity cubed. So 6 gets cubed and x gets cubed. The only thing I think you might be able to do is divide that by 4. And then you would get, what, 54? All right, so that would be completely simplified, as much as possible condensed. All right, any questions? Let's talk about why that negative exponent goes to the denominator real quick. Let's say we have this, log base 10 of 10 to the negative 1. What does 10 to the negative 1 mean? 1/10. Can you see how if I put this negative in front of here, then it would become negative, and then it would be, if I did 10 to the what is 10, I'd get negative 1, right? And that's the same thing that I would have got if I would have actually done 10 to the negative 1 and gotten 1/10, right? Then I would have gotten the negative 1 that way as well. So anytime we have a negative in front, the value is going to go in the denominator because it's really can be thought of as almost like an exponent, as like a y to the negative 1 type thing, which would make it go to the denominator. All right, any questions over any of this? All right.